technically streaming, so I wonder if anyone joined us on YouTube, but feel free to say something. We will kind of look at it as time allows. All right, give you guys another couple minutes, and then we'll get started. It's super interesting watching myself on the feed. I messed up a little bit of our video setup today. For some reason, my camera didn't want to work, and then I didn't bring the audio converter to take my XLR microphones in there and hook them up to the machine. So sorry for those of you that are joining us online that are having a hard time hearing me. That's my fault. So we'll get it better next time. I'll try not to forget the equipment at home. We'll give Eric a minute to come back. Right. How's everyone doing? One more day before Friday? How many of y'all work in the building, if I may ask? Oh, cool. So startups, I assume, everybody? Awesome. But not right now. No one's going to play that. Yeah. I upload them directly. I don't know if I can. I did it through SlideShare last time. Let me do that after the meeting. So welcome. My name is Mikhail, and you're here at base meetup for Birmingham area software enthusiasts. And we're at the DevOps Lunch and Learn. And I started these last month, and the goal is to continue them all until the end of the year to teach the things that are not as popular in town, right? Like Kubernetes. So before we get started too far, thanks to the Depot, Trimicro, Dallas. Dallas is my new startup, by the way, and technically they paid for the food. So, thank you guys for coming. Without you, it wouldn't really. I'll be talking to myself. That's not fun. I answer back. It's weird. All right, so we got a lot of stuff going on this month. We have, you're here today for the DevOps Lunch and Learn. We're doing a roundtable next week in the evening, kind of like talking about company culture and company size. And Dr. Lindsay Sutton, who else is going to be there? Nathan McMinn, he's from Conserve. Lindsay is with SHIP. And Katie Ford, she's a woman who code. And then I will probably sit down with them and talk about different size companies and what things you should watch out for. Then on the 19th, we're going to have two events. At lunch, we're going to do the JavaScript Lunch and Learn, Dockerizing Node.js apps. So it's the practical mixture of our JavaScript and our DevOps Lunch and Learn, basically getting your apps into containers. And then at night, the game developer virtual meetup is going to happen, and they have a Vulkan kind of contest that they do every year, so I think they're presenting today, or they're in the middle of working on little apps that are related to Vulkan, so little games and stuff, so it's pretty cool. And they're doing a lot of Unity stuff, so y'all are interested in that. And then we'll have all your base on the 26th, and Amazon is going to be there providing printers, so you didn't hear that from me. Alright, so, let's get started. Let's talk about Kubernetes. So, what is Kubernetes? And at the very core, Kubernetes is an container orchestration platform. And what that means is that, right, it's just there to manage containers. Some other container orchestration platforms that came before it was Docker, right? Docker is both a runtime and an orchestration platform, and an application and a bunch of other things. Howdy. And then, there was also Mesosphere, if any of you have used that. They have their own API, but they also, are Kubernetes compatible, and they kind of finally made the switch all the way to Kubernetes. And a lot of companies, when they were first doing containerization orchestration, they went with Docker or Docker Swarm. And then as Kubernetes kind of won the orchestration platform war, they migrated. And so the company I work for, SUSE now, but Rancher Labs formerly, they had, Rancher 1 was built off Docker Swarm, and then for Rancher 2, they threw all that out and they rebuilt it on top of Kubernetes with their own Kubernetes. Actually now 3 Kubernetes distributions for different use cases. And so Kubernetes in general, it's powerful, it's open source, and it manages workloads. It has a declarative syntax that we'll cover here in a little bit, and it is self-extensible through custom resource definitions. So this is what makes Kubernetes so powerful, is you can literally make a definition of anything you want and give it an API to validate itself. So that API can be a microservice that's running in the cluster. In fact, it probably is going to be a microservice running in the cluster. So you literally can extend it any way you want. And in fact, the built-in resources are resource definitions as well, right? So they are in there, and we can take a look at one a little bit later on. But very extensible, so you can do all sorts of crazy stuff in it. And there are many flavors of it. Just like I mentioned, Mesos, they have one, Rancher/SUSE, we have 3. VMware has 1 or 2, Tanzu, and they have like a K08, which is like a edge release. Rancher/SUSE, we have one too called K3S, which is smaller than K8S, and they're binary compatible, but we ripped out a bunch of things that, like cloud providers, that you wouldn't use on an edge device, right? Your ARM Pi is not going to need to talk to Amazon Web Services or anything like that. So there's, so depending on what your use case is, you should probably use more than the vanilla distribution. You should look at the different choices, because they will affect your requirements for resources and availability, right? So do you want just one master node because if you reboot it, it's okay? Or do you need like some high availability, redundancy that uses a data store underneath it called etcd, and we'll cover that in a little bit. But that one requires 3 different nodes to maintain high availability because it like has a voting system. And it's called something called the RAP protocol, which don't know much about as far as the details of it, but basically you need an odd number in order for it to be able to vote. So you can have 1, or you can have 3. When you have 2, they both fight for control. So high availability in Kubernetes usually means 3 nodes. So because you can still only lose one of them. Well, actually, no, I guess in that case you can lose 2, but if you lose them together, then the one that's left is not going to know that it's the only one left, and then it has a bad day. Alright, so many flavors, let's not get too deep there. So let's talk about the architecture. So there are really 3 components of Kubernetes. There is a control plane, and control plane is just the API endpoint. That is what you talk to. If you want to get anything done, it's their REST API service, basically. And it's not exactly REST, but it's their API service. Then there's the etcd that I just mentioned. etcd is a database that uses the RAP protocol, and it It is what the majority of Kubernetes distributions use as its data store because of its ability to be resilient when you have 3 of them or more. There are some exceptions like K3S, which is a SUSE Rancher product. It's meant for the edge, and it can use SQLite. So, but think about SQLite, right? It's not, you need to back it up, right? It's just going to sit there in a file system, and it's not going to do anything else for you. So if you're not taking care of backing it up, you may lose your data. If you're not going to, so you're always going to be trading off resiliency for speed and data size. So the third is the worker. That's the third component. And the worker, that's what actually runs your containers. Now, there are different flavors of this, and in here, the worker is the node, really. So, yeah, I probably should put worker on there, but in order for the workers to know what they're doing, they have to talk to the control plane, and then the control plane interacts with etcd to figure out if it's allowed to do what it wants to do. etcd is your source of truth. So now a lot of distributions also combine, and in here master is the control plane in this case. They combine the control plane and etcd into master. So a lot of times you'll see those as just, it'll say master, and then the node/worker is often referred to as agent. So it depends on the distribution, and probably could have done a better job on the nomenclature, but for all intents and purposes, a node in this case is a worker, and then the control plane is the master, and that's what you talk to. So when you talk about high availability, you usually need a minimum of 2 control planes, and then since etcd requires a minimum of 3 to be highly available, oftentimes we just have 3 control planes, 3 master nodes, and we combine the etcd and the control plane roles. And the reason for this is because if you think about it, the control plane is just an API. It has to know where to get its decisions from. It has to know the source of truth. So pretty much every request you're talking to your data store. And it's a lot faster to talk to your data store when it's local. So in the end, Rancher made, and /SUSE made a decision to really combine them going forward. So the 2 new distributions, the edge one called K3S, and then the Rancher Kubernetes Engine 2, RK2, they both combine etcd and the control plane into the master node. So other distributions do different things. So you may see master, you may see control plane, etcd, but those, think of those as the same thing. And then you'll have the worker role, which is really unchanged. And that's what runs your application workloads. All right, so before we move on to that, questions about the architecture? Any comments, suggestions? Any experience with Kubernetes and high availability? Okay, cool. It's fun. Until it's not. All right, so Kubernetes uses a declarative syntax. It is usually either YAML or JSON encoded, but for, to make it human readable, most people just use the YAML, but you can output, the data as JSON as well. And you usually do that in your pipelines so that you can use JQ to pull pieces of the data that you need, or JSON path as well. So this is what a object looks like inside the system. And I'll show you what a CRD looks like in a little bit. But in this case, this object defines an API version. So this is going to be app/v1, which matters. And then it's a kind, right? It has a name, and that name is the deployment. This is one of the standard objects inside Kubernetes. But if you had a different object that you create a definition for, you would define it the same way. There's literally no difference. You would have a different API version of a different kind, and you would have different data in here in the spec. But pretty much every object is going to have something called metadata. And in that metadata, you're going to put in a name, and possibly a namespace. Because Kubernetes divides things by namespace. I'll show you that in a little bit. And you may have labels, so we'll touch on those later as well. Now, the important part here is the spec. And can everyone see the spec portion of it? Okay. So the spec is the specifications. and it has to match the definition inside Kubernetes. So different versions of Kubernetes will have slightly different specs for things, right? So deployments, usually it doesn't affect you, but on the edge cases, for example, there's a version of Kubernetes called 117, I think, and before, they didn't have a special type of probe on that you can add to your workloads. It's a startup probe that until it returns true, you don't do any of the probes, right? It's like this process is starting up. So that didn't exist before Kubernetes 118, I think. And so if you try to put that in a deployment in an earlier version, it would ignore it. So you wouldn't get that functionality, and that might cause other issues. So keep that in mind. Your API version should point to what the proper setting is. And if you go to kubernetes.io, and by the way, this is one of the best resources for Kubernetes. I highly recommend checking it out. In fact, this is one of the ways I learned Kubernetes. Is I went to the website and actually I found MiniCube, which is what we're gonna look at today, and they had this excellent tutorial. And I followed the tutorial and got my MiniCube is a distribution of Kubernetes that will run on your machine. It's for developers. It's probably the easiest way to get Kubernetes up and running on your machine. So, and it will create a single node kind of cluster that you can deploy resources to. And we'll do that in a little bit. But yeah, so kubernetes.io, and then MiniCube is the local distribution. Let's go back to that. Okay, so let's look at some of the things here. Under spec, we have replicas. So a deployment defines a number of objects. And if you look on the right, it has the three little things. There's the three different containers that it can be, because we have three replicas in there. It just means three copies of whatever is down in the template spec. So if you look, there's a spec on top, that on the root level, that defines the replicas. It also has a selector, but we'll come back to that. And then it has a template area. And in this template area, what it is defining is what each of the pods, what each of the small containers is going to be, right, inside each of these deployment units. And here we're going to use a container, and it's going to be just one, but you can have many. So unlike Docker, you can have a multi-container pod. And so the smallest unit in Kubernetes is really a pod, it's not a container. And a pod can have multiple containers, and they all share file space, and they can you can intersect each other's ports, basically. So the reason why that's important is because let's say you have an Nginx container, and you want to run something before the request gets to it. You could intercept the connection on TCP on port 80 and then forward it on to Nginx, but after you do something with it. And it's this functionality of like intercepting data is used everywhere in Kubernetes. We use it for security, to scan things. We use it for offloading data for monitoring and logging. So the ability to use multiple containers that are kind of sit together and have different functions allow you to maintain a single purpose. I forgot the name for that. Anybody? When the thing does one thing only. Anyway, regardless, you can have multiple things that do one thing only that all talk to each other, that share the same data space. So you can, they can use the same variables, and they can share files. Alright, so multiple containers or one container, and we're going to have three of them. That's what this basically says. Also, it labels it, and there are two sets of labels. So in the template, when you put something in the template, that is going to be applied to each instance of whatever it is you're deploying. So in this case, we're saying in the template, we're going to add a metadata label called app Nginx. App equals Nginx, basically. And then in the deployment, we link it by creating a selector that says, this deployment encompasses everything that has a label app nginx. So you have to have both of those there in order for them to be associated with each other. So you're saying, this deployment matches anything that has app nginx, and in the template, I am making it have app nginx. All right, that was a little confusing, I kind of went on, but questions about deployments specifically? Okay, let's move on to,
Can I ask a question about pod?
So
if a pod has multiple containers sharing resources, is it possible for one container to bring down the others in a single pod?
oh, absolutely. If one of the containers fails, then the whole thing gets restarted. Or depending on, you can set rules on what happens, but yeah, the whole thing basically breaks. There's no, you can't have one that runs without the other. Speaking of pods, let's talk about it. Sorry, go ahead.
I have a question. Is there like any limit to the number of abstractions you can do if you have containers that have pods that have containers that have pods?
Yeah, so there's a single level. So you can have, at the bottom level is, I guess, technically a container, but the container is not an object inside Kubernetes. The pod is the object. The container is like an attribute, I guess would be, or maybe a sub-object, but it's not, you can't really reference them without specifying which pod it's in. So that's why I really view pods as the smallest unit. But you can't, like, a deployment can have a number of pods. Pods can't have deployments. And then a pod can have any number of containers, but that's it. Like, there's no further layering that can happen.
Okay.
But at the top level, you don't have to have a deployment. You can have either a deployment, a stateful set, or a daemon set, and we'll cover those in just a little bit. But there's like a level that groups different pods, and there's like three different items. There's a deployment, there's a stateful set, and there's a daemon set. And those are three different groupings of pods, and then there's pods. And those pods, are variable with the number of containers depending on your workload. So containers, pods, and then a grouping of pods. And we'll cover the grouping of pods here in a second. I'll go through. So smallest unit of a deployment or a daemon set or a stateful set. Yeah, it is basically a pod is like a VM, right? You can't have a container VM because multiple VMs can't really share. Well, they can kind of share data, but they don't share resources in the same way that a pod, the different containers in a pod do. They have more like different processes on the same VM as far as containers go. And then you can have more than one container, or one or more container, and it has some resources. So pods have storage that can be linked to them. They can have special networking interfaces that can be linked to them. Kubernetes also has the ability to abstract the networking layer and the storage layer. So we'll cover that in just a little bit. And it can be scheduled to run on worker nodes, but it can also be scheduled to run on master nodes. So just because something is labeled a master node does not mean it can't run things. It usually means it has something called a taint, and we'll cover those in a little bit, that says you must have a certain variable in order to be able to run on this node. And so your master nodes really serve as workers as well, but only for specialized workloads, for things that like etcd or the scheduler or the API. So questions about pods? Okay. So let's go back to deployments a little bit. The reason why you want to group pods together is for scaling usually, or for handling, a horizontal size of more than one of something. And it does it really well. It has the ability to control how it updates, how it scales. So you can create rules like, I want only 20% of the pods in this deployment unavailable in the middle of an upgrade, and it will only, allow 20% to go down as it does the upgrade. You can have it set to where it brings new ones up first before it shuts down the old ones. So the different settings you can set to control how these things deploy inside a deployment. So for most applications, we use either deployments or daemon sets. And we'll cover daemon sets right after this. I don't know if we have a slide for it, but I'll go through and cover it. Yeah, I don't. So there are two other ways of grouping pods other than deployments. And we will go. And by the way, yeah, Kubernetes.io amazingly well in Google search. Access amazingly well via Google search. So a daemon set is a lot like a deployment. So it has an API version, a kind. It has a spec that has a selector, and then it has the template where you define what the pod looks like. The pods look like. The difference is that a daemon set runs on every node that matches its taints and its selectors. So a daemon set will run, the goal of a daemon set is to be a daemon that runs on every node within, a certain label set. And why you would use it is if you need features that are present on every one of the nodes. For example, the storage driver you may need on every one of the nodes. If you're doing a lot of DNS queries, you may want to have core DNS on every one of your nodes. Any kind of controller that your application has to talk to locally, you would create a daemon set. So let's see, what did I use the daemon set for last? I think the log collection and the monitoring, those are the two primary uses in the standard that you can get packaged. Because for the logging component, all it is FluentBit or FluentD sitting on the node, and I don't know if any of you remember collecting data or have collected data outside of Kubernetes. You'd use something like collectD or FluentD to grab the data from that node for metrics or logging and offload it to AWS for CloudWatch or wherever it is you're doing your monitoring. Well, moved into Kubernetes, it works the same way, and we call it a daemon set. And it just means one of these things will run on whatever nodes match the selectors. So unlike deployments, where in deployments we specify the replicas. So we say we want 3 of those in a deployment, whereas in a daemon set, we say we want 1 on every node. And you don't get 2 on every node, you just get 1. That's no more, no less. All right, so there's a third type of data that groups pods, and that's called a stateful set. Oh, there it is. Stateful sets are used for databases, basically, for data stores that need resilience. If you spin up a version of Postgres that comes with Kubernetes, you're going to get a stateful set for your data store. It is kind of its way of handling data replication. So you still have replicas like you do with deployments, but the goal is slightly different, and you share data, right? You have in here we're specifying a storage class is how we're pulling that data, but you could also define the specific volume that you want. And we'll talk about storage here in a second. This is the one that I have actually least experience with, because for a while it was said don't put databases in Kubernetes. In fact, 2019 DevOps Days Houston, I was told by multiple Kubernetes experts, don't put databases in Kubernetes. Guess what? We put databases in Kubernetes now. It's the technology has gotten better. The key is that you have replication either within the stateful set and the application itself. Like Postgres has replication, right? You can use that in combination with stateful sets to replicate the data. Or you can use a different type of storage called block storage, where it replicates the data for you underneath. And with that, you have some. How many of you have used SQL database? Okay. How many of you have had to migrate that database when it exited improperly? Okay. So have you had data corruption issues? So replication, if you replicate halfway through a transaction, you can have an inconsistent state that can break the database. So you have to be very careful when you're backing up and replicating databases that you have multiple backups, or you do it in a way that stops the database before it does the replication, or before it does the writing of it. And there's several ways to do that, but if you don't do it, you get what we got, which is you get inconsistent states, and the database won't spin up because it has like half a transaction in there. So for acidic databases, you want to pause transactions between backups, or back it up to a separate machine that you can pause that's not running live data. Or use something like a stateful set that helps manage some of that. I don't know enough to really be able to do it myself, so I would have to look at instructions. But it is possible, and you can manage data inside Kubernetes.
So this, would you just send it as a text message or like this? Do you have the stateful thing that you want to send them declarative?
It would create several versions of it. It would create several pods that were linked in a stateful set where they would replicate data.
Okay.
So deployment, whether it's deployment, daemon set, or stateful set, it creates a bunch of pods, but it doesn't give you a way to access them. So Kubernetes went through and created this other resource called a service. And a service is like a DNS record that can have multiple endpoints. And it also has a selector. But it can expose an application. It can expose multiple sets of pods through a specific DNS name inside the cluster. It allows you to scale horizontally your number of pods, but still be able to access it through a single host name. Or you can do it through its own IP address. Inside Kubernetes, it runs its own DNS service called usually core DNS or QDNS, and it manages the service references. And it uses the name of the service and the namespace, the location where it's at, to be able to reference it. And it also gives it its own IP address out of its own IP address set. So through that, Kubernetes will decide where to direct your traffic based on the configuration of the service. You can have a service that says, I only want local traffic. So if an endpoint is not available on that node, that request will fail. Now, if you remember a couple minutes ago, I covered daemon sets that put one on every node. The combination of a daemon set and local traffic in a service gives you basically a convenient controller that can be accessed on any node, right, through the service endpoint. And it will make sure that it's only on that node. Now, if you set it to allow cross-node traffic, then Kubernetes will use its own internal system to direct that traffic to another node that has a pod that matches the selector for the service. And underneath it, there are a couple other things that get created. We don't need to mention them right now, but like there's another reference called endpoint that gets created, and that's how the service knows where to direct it. So when a pod spins up, it creates an endpoint. But those things are done for you. You control the deployment, the pods, and the services, and then Kubernetes kind of does a lot of this for you. And why would you do this, right? Because pods are more. Pods, your workloads can exit, it can run out of memory. A lot of things can happen. So you never want to access individual pods directly. You want to either access the deployment, even if it has only one replica, or the daemon set, or stateful set. And you can do that all with labels by putting the matching labels on the services. All right, and then the other thing services can do, which is pretty cool, services can automatically create an endpoint IP address if you're in a cloud provider. So most Kubernetes distributions don't strip this out. A couple do, like KPS, but if you create a service of a type load balancer, the cloud controller inside Kubernetes will ask the cloud provider that you're in if it can identify it. So it supports DigitalOcean, AWS, Azure, right, Google Cloud Platform, all of those. And with this special module, it can even support your local, your local lab through something called MetalLB. But basically, if you have a load balancer type service, it will try to request an IP address from someone. If you're in a cloud provider, it'll request it from the cloud provider. If you're local, it'll try to request it from MetalLB if you have it running in your cluster. And that will, if the response back is an IP address, that IP address is valid and usable. And this is important because it is a security issue. So if you don't have controls set up on your cluster and one of your developers creates a service that is a load balancer type, if you don't have that restricted, then that is a valid internet-facing endpoint that can be accessed by an external person, right? Depending on your rules for your VPC and all the other things. But what a load balancer service can do is it creates an external access point. And if you don't control that, you can expose something like Spark that allows people to write journals, anonymously if you don't configure it right. And I say this and I emphasize this because at a previous company, this was an issue. And so you should always control your load balancer type services, and you can prevent that by putting in a admission controller that tells it not to allow that, right? Unless you're a certain user. So you could also have notifications. There's several services that offer notifications to let you know when certain things happen in your cluster, and you should definitely run those on production systems and have it alert you when a load balancer type object gets created, or really anything with an external IP address, because that is a new possible vulnerability for your cluster. All right, let's see. That's really all I have for services. Let's talk. By default, services are internal to the cluster, and they're not accessible outside. There are two ways to access, really two ways. Node port is the one that I haven't covered. Node port says, I want to be available publicly at a certain port. And that port is usually between the range of 30,000 and 32,000. That is a Kubernetes default thing. You can change that, but I wouldn't. It allows the service to be available on whatever IP address of the nodes, right? So depending on the routing, again, if you have a router to be local only, that if that node has a pod that matches the selector, it will return that it will push the data to that workload. If it's not on that node in local mode, it will just fail the request. If it's in cluster mode, then it will internally direct the traffic to the right node. So it's underneath, it does a lot for you if you know how to use it. And for the record, nobody knows how to use it at the beginning. I ran this in production 2 years ago. After seeing a demo of it, basically, and I was like, wow, this saves me so much time. I don't have to write my own infrastructure management. And it's pretty cool. Alright, so more about the services. So I just mentioned the load balancer type, right? That will create an external IP address, but internally inside Kubernetes, it has the endpoints of each individual pod on it. And the service reference, which is like a DNS entry, knows where to direct the traffic, or whether it can, right, depending on the traffic policy and which node it's on. Okay. Yeah, so when a pod disappears, it removes it from the service pool and from the endpoints resource, so it no longer registers. But all this takes a couple seconds, so you should still have a lot of validation in your stuff. Your services, microservices, should still fail cleanly, because you may have a few seconds where a request gets lost or something, So keep that in mind. It is not lossless. When it spins something up or down, you can have traffic that gets lost. Not a lot and very quickly, but still. And then when a new pod gets replaced, one more thing is, if you have a deployment and you have three replicas, if one of those pods dies, it will replace it automatically. So it will maintain its number of replicas. And with the daemon set, if a daemon dies, it will replace it.
I'm following.
Yeah, I know this is a lot. It's 1 hour is not enough for Kubernetes. I actually thought that was that. All right. So we know a service can create an external IP address or be accessed on an external port. There is another thing that makes Kubernetes awesome, and that is the ingress control, the ingress type. And this is not so the ingress is a built-in feature, but it doesn't really work unless you have an ingress controller. And that is just an application you install in your cluster. The most popular one is Nginx, and I'm sure most of us who have had to do web development have looked at Nginx at least. But it also supports traffic, and then there's cloud-specific ones like Azure has a ingress controller. I believe there's an EKS one as well. Yeah, so the cool thing about an ingress is it has a host name, and it is like the virtual host of an Apache config or the host selector of the Nginx config, right? It matches a domain, and then the cool thing is it can direct traffic. You can point to your workload on a path as well as a domain. So you can have multiple path services, right? So Mikhail.com can go to WordPress, Mikhail.com/store can go to my, well, not Shopify, but they can go to my Magento store or my whatever. So it makes it really easy to have multiple services on the same domain. And it can handle the SSL termination for you and special rules, just like you have an Nginx where, the amount of settings that you can set in Nginx, it matches basically what you can do in both Nginx ingress controller. So all the things that you can pretty much set as part of a normal Nginx configuration, you can set it in your ingress controller, or you can set it specifically. The cool thing is you can set it specifically on each ingress for a lot of drivers. So let's see, ingress controller applications. And we do that by setting these annotations, which are a lot like labels, but annotations are like labels that are used for stuff. So whereas labels allow you to select on things, annotations define functionality. So in this case, the Nginx ingress supports a bunch of these different annotations. Like you can even have it do authentication for you. So all your application has to do is serve data and use JWT tokens. And if one of those tokens, if it comes back improper, it will redirect it to the login page. So it gives you a lot of pre-built stuff that you can use. You can also set up cores through this. You can set up proxy settings to this. Like literally, it's every Nginx setting you want. And the ones that you can't do as an annotation, you actually modify the configuration of the ingress controller itself, which is Nginx underneath. But similar stuff for traffic. And traffic is not spelled like you would think. For those of you who haven't. So traffic is what we use for our KPS. It's, I think, slightly lower resource constraints. But the traffic proxy is pretty cool. There's also HA proxy, if you're familiar with the older tech. HA proxy, there's a HA proxy ingress controller. I don't think many people use it, but if you were doing the cloud back in 2010 or so, you might still be partial to it, like me. All right. Oh yeah, I forgot I had this slide in here. By the way, some of these are work slides that we go teach every day. But all right, so this is what an ingress definition looks like. It has a name, just like pretty much every resource has to have a name. It has an API version, and if you notice, this one is networking. It's it's part of the networking stack. And then in the rules, it has the host name. And by the way, it can support multiple host names, so you can have as many host names in there as you want. But each host name has to have its own path set. So a little bit of duplication there. And then you can have multiple paths and path. As you can see, foo can go to service A, far can go to service B. And this is one of the ways you can do blue-green deployments too. If you have version of application A you can just switch in the service what the label is, right? So the service points to application A, service can now point to application B with just updating that record, and then Kubernetes will make the changes. So flexibility to be able to direct traffic both at the ingress level and then at the service level, right? So here at the ingress, I could just switch the service that it's pointing to, or I could also, in the service, switch what the label that I'm pointing to is. So there's several ways of directing. It's really flexible to direct traffic any way you want. And one more note, the service port in here, this is an internal service port. This is not externally accessible. This isn't the node port. This is, so in Kubernetes, you have usually your own network. You can use your main network and expose your individual pods to your whatever network is. But most of the time, we don't recommend that unless you need something like IP, unless your security team needs to be able to look inside traffic between your pods, or you have you have really low latency requirements, which happens in telecom all the time. But for most cases and for web traffic, we recommend you use something called VXLAN, which is a virtual network inside Kubernetes, meaning that these service ports aren't actually accessible outside of the cluster. So they're accessible inside, but not outside. So, yeah, in order for that service A, let's say, to be accessible outside on that it would be really difficult to make it accessible on that port because it's outside of our node port scope. It would be easier to make it accessible as a load balancer with its own custom IP address, and then have that direct traffic. But then you still have actually at that point you can use one of those service ports. So AWS will actually spin up a load balancer for you in certain cases, and then have that as the external port of the load balancer, and then direct traffic to a node port that's accessible in your cluster. And it allows you to stack them. So externally, you're accessible at, like, let's say 4200, but internally, that may be port 32,000 or 31,050, and then it can stack them. And Kubernetes, in most cases, is smart enough to dynamically provision those node ports. So, let's say you have 10 different databases of MySQL that are normally running on port, was it 3360 or 633, something like that. Anyway, so let's just say it's 3606 or something like that. Because it's assigning a new IP address and it would create a new load balancer for you. You can have that port on that custom IP address, but inside your Kubernetes cluster, you would have, a different port. It would really be like 3101, 3102. So there's it gives you a lot of flexibility of how you do it. Just keep in mind that these service ports are inside the cluster. That's the key thing. I've been going on for a while. That's really all the resources that I wanted to cover today before we kind of get in. We only got 10 minutes left, so I'm going to try to do a little. Go ahead.
I have a question.
Yes, sir.
So is that just inside the cluster, or are you trying to see the difference between that and the load balancer?
No, so it is external to the cluster. The difference is an ingress has an ingress controller that's driving it, so there has to be a special module called an ingress controller. And that ingress controller is what takes care of the HTTPS stuff and the hostname routing, like, for example, foo.bar.com. The ingress controller reads the ingress definitions and sees that it has a foo.bar.com. A load balancer access would be straight access to your service. So your service would be responsible for creating, for handling the HTTPS connection, like processing the request, and it's direct access. And it's really meant for more things like databases, right? Or things that don't require, that have their own security built in, that have their own features and that you need access to directly. By the way, the ingress controller is deployed as a load balancer. So usually, when you deploy an ingress controller, especially in a cloud provider, you deploy it as a type load balancer service. because it handles those extra things for you, like translating between a path and a domain name and a service center. So load balance, so you can create your own Ingress controller very easily by doing a load balancer type service and then doing something with it, right? So, does that answer?
Yes.
Awesome. Any other load balancer slash or Ingress or so Ingress is external, I guess, and load balancer is external. Ingress just does more for you.
Thanks for that. That was
Yeah, I'm sorry. I've been going like at 100 miles, and again, 1 hour is just not enough for Kubernetes. So because Kubernetes is so huge, it's a vast ecosystem. Everybody pretty much has their own version of Kubernetes, and then a lot of things that you normally use will have something called charts, Helm charts that will deploy a version of that stack into Kubernetes. And I'll show you a little bit of that in a second. Fine. But before we go into that, we need to learn how to interact with Kubernetes. kubectl is a command line API tool for talking to Kubernetes. It requires a config, a kubeconfig that tells it where to talk to, gives the endpoint of Kubernetes, and the security information like a token or a security certificate to talk to. Helm is a package manager for Kubernetes. If you're deploying an application into Kubernetes, you should really be using a Helm chart. And a Helm chart is a package of manifests. It's a package of resources, or resource definitions as well, that you package together. We definitely don't have to, that's like its own 2-hour class, just on Helm. And then there's, the other tool I want to mention is Terraform. Terraform is one of the most cross-platform ways of doing infrastructure as code, and at least on the Rancher side, like our Rancher 2 controller and our RKE controller, we spend a lot of time to make those as fully featured as just talking to our API. And so you can do a lot of things in Terraform, as well as control all your different cloud services, right? You can control AWS, GCP, and Azure, all with similar Terraform code. So these are the 3 tools that I think are pretty much a requirement for being able to work with Kubernetes. You need to understand kubectl, command line tool. Helm is both a command line tool and a charting kind of definition of a package. And Terraform is the way that you automate it all. There's some other ones. There's Plumi, I think. If you don't want to use Terraform, you could also just do bash code and upload your resources with kubectl. And so let's talk about the local deployment, and I would like to be able to at least spin it up. We may not be able to, but let's see if we can give it a try. So on your local machine, and I'm using Windows, but this is a lot easier if you have a Mac or Linux system, because you can literally just install MiniCube. But if you're on Windows, you have to have Hyper-V running. You have to have Hyper-V off and enable either Intel V or AMD V, and it is incompatible with Windows subsystem for Linux. So right now, my Windows subsystem for Linux runs, and this allows me to run Linux inside Windows. But in order to get MiniCube working, I will probably have to break it. Let's see. MiniCube start. Oh my gosh, it's working. That is amazing. Okay, cool. All right, so in order to get here, what I had to do was, let's go back to our MiniCube page. So I selected my executable. Basically, I downloaded the executable. I added it to my path, and I copied it to C/MiniCube, and then I added it to the path. And then I did a MiniCube start. But you have to have a few things enabled in order for that to work. Just keep that in mind. It will tell you what you need. It will say you need virtual machine support, and then you can add that feature to Windows. But so let's go back to our PowerShell. So restarting existing virtual box. Okay, so let's give it a minute. It shouldn't really take too long. And we'll open up a new tab. kubectl installed, but you can get it from kubernetes.com. So kubectl, get pods. And what I'm saying here is just get all the pods with -a for all the namespaces. And if MiniCube is up, that would work, but I don't think MiniCube is up. Now let's keep the comment come on. Let's instead start on this page, because I opened this one up as administrator. I did not open the other up as administrator. I think that may be a part of the issue. Let's see. Alright, okay, that was it. So it's starting up. Keep that in mind. If you're starting MiniCube, you do need to do an administrator in Windows. There are other distributions you can use. You can also Docker. It now comes with its own, like it has its own kind of Kubernetes server. So Docker Desktop has its own thing. I learned when MiniCube was the thing, and I still really like it. Yeah, it does take a minute to set up. So, and if you notice, it's I don't know if you guys can see that. Let me go a little larger. Oh, I think it's too large. Do it right. Okay. So, I don't know if you can see that, but it's running on Docker 20.10.6. And underneath it is running Docker as the runtime. Now, there are other runtimes for Kubernetes. There's CRI and there's containerd. But the first one and the one that's still most often used is Docker underneath. But even Docker itself uses containerd to actually run the container. So in a container orchestration platform like Docker or Kubernetes, you have the things that tell the system which containers to run, and then you have the thing that runs them. And the thing that runs them is usually the containerd or CRI, containers resource interface, something like that. Alright, okay, I don't think this is going to spin up in time. We only got 4 minutes left. But here, I will show you guys a little bit of what Terraform code I do in my day job. So in here, we define providers, which say this is how we access these type of resources. And here I'm grabbing Rancher 2, which is my company's resource. And then I am creating some AWS instances based. Oops, that's an issue. I'm creating some AWS instances based on that here in the AWS instance section. And then I am running RKE on top of that, which is RKE. So then I'm creating an RKE cluster on top of that with the nodes that I just created. And then I'm installing Rancher on top of it, which is actually, so this is the bootstrap, which is done through a Helm chart. So, but all of these things can be done through Terraform, which is why you can do both the Helm installation, install your Kubernetes, deploy your instances, install your Kubernetes cluster on top of it, install Rancher or whatever, and then deploy your things through Helm. And all of that can be done through Terraform. All right, I'm going to cut it off here. We have 1 minute left. I'm sorry we kind of ran out of time. If you have questions now, we can go through them, or if not, if you have some later on, reply to the meetup. I'll do my best to answer them, and I'll post the slides up. Questions, comments, suggestions?
Before I leave these slides,
I'll post them to the meetup and a slide share, and then put a link in there. And then as you're learning, if you're serious about learning Kubernetes, Kubernetes.io and then MiniCube, those are great places to start. And then there's a paid class from Udemy. Normally it costs it's always on sale as a new user. So never buy it at full price. It's like $200 at full price. But whenever it's this guy, Mushad, he makes the best Kubernetes classes. So I bought his Kubernetes administrative class, and I'm about halfway done with that. But he also has an intro class, the Kubernetes for absolute beginners, and you can see it's on sale for like $15. So never buy it at full price, but at $15 it's really worth it. And he's got like labs that he'll help you do with it, and yeah, it's just definitely worth the money if you need to be guided. If you don't need to be guided, you can guide yourself. Kubernetes.io, excellent resource. It has all the things in it. And if you're looking for like the API, like I was somewhere in here there's an API, but it will tell you which versions of things it's talking about, and you can have a drop down of different versions. You can see the different versions. Anyway, all right, we're done. You guys can go ahead. Appreciate y'all coming. We're gonna see y'all hopefully all the time.
Thank you.